Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Writing and Language section, passage number 3, question 24. Alright, this question comes up at the end of the first paragraph in the passage, so let's just read down to there. Alright, it has long been known that the sea otters living along the west coast of North America help keep kelp forests and their habitat healthy and vital. And here, answer choice A was the right answer to question 23, so we're just going to leave that as it is. They do this, they help the kelp, by feeding on sea urchins and other herbivorous invertebrates that graze voraciously on kelp. So the sea otters, they help the kelp by feeding on sea urchins, the sea urchins and other herbivorous invertebrates that graze voraciously on kelp. So urchins eat kelp, and otters help the kelp by eating the urchins. Urchins eat kelp, sea otters eat urchins. The more urchins they eat, the less urchins can eat the kelp, the more the kelp gets helped. With sea otters to keep the population of sea urchins in check, kelp forests can flourish. All right, now we're going to get to the sentence in question. In fact, 2 years or less of sea otters can completely eliminate sea urchins in a coastal area. See the chart? All right, and we're going to look at the chart in a bit, but first, we've seen this question 24. We're going to go over to question 24 in the questions and read it and ask ourselves, do we have enough information to answer this question now, or do we need to read more in order to get more context? Well, let's look at the question. Which choice offers an accurate interpretation of the data in the chart? All right, so this is a quantitative information question. It's a question that's asking us to read and interpret the chart. So we do need more context to answer this question. We can't just answer this question based, for example, on how this sentence is worded. This isn't about where should we put the commas or, should we use this word or that word. Really, this is just a question about this chart down here. And we're just going to match each of these 4 claims in here to what the story that the chart tells in the exact same way as we would if this were in the reading section. All right, so let's get an understanding of what the chart looks like. Let's start with the title. Effects of sea otter presence on kelp and sea urchin density in coastal areas. All right, so this is a chart that shows the effects of something on something else. So it's sea otter presence. It looks like whether sea otters are there or not, maybe. And it's the effect that sea otter presence has on kelp and sea urchin density. So sea otters are going to have an effect on kelp density and sea urchin density in coastal areas. All right, so let's look for that to happen in the graph. And here we're going to start with our axes. Let's start with the x-axis. Here we're thinking about coastal area. And this is a strange label for an x-axis. Thinking about normally x-axes or axes in general are numbered. You see the y-axis goes from 0 to 60. Here the x-axis is like coastal area, like 0 coastal area to 60 coastal area. Like coastal area doesn't seem like the kind of unit that you can have like a number of. How much coastal area do we have? So we can look in more detail about this x-axis, and we can see that there's 3 coastal areas, I guess, that we're looking at. And we want to, shove these 3 into this box. How are these coastal areas? Well, this apparently is a coastal area with no otters present, whereas this is a coastal area with otters present for 2 years or less. And maybe here you can start to see like how this makes sense that the x-axis, as we move along the x-axis, we're varying on the variable of coastal area. Here, it looks like they went to 3 different coastal areas. And the 3 different coastal areas differed in this sense. One of them was the kind of coastal area where there weren't any otters. There were no otters in this coastal area, right? Then they went to another coastal area where otters had been present for 2 years or less. So they went to a different coastal area. Otters are there, but they're pretty new in town, right? And then they went to a third coastal area where otters were present for 10 years or more. This is like the otters have set up shop. They're the main animal in the coastal area, and they're all over the place, and they've been there for a long time. All right, so these are 3 different coastal areas. That's what's going on in our x-axis. Now let's look at our y-axis. The y-axis measures density, number per square meter. How many of the thing are there in every square meter of, I guess this is probably ocean is what they're measuring. These are sea creatures. Okay, so this is a graph that shows the density of sea urchins. And this says this black square is measuring sea urchins. And we see, oh yeah, this black bar, this is the sea urchin density. And kelp density, here this gray bar is going to show the density of the kelp. Here's the density, kelp density. and it's going to show the sea urchin density and the kelp density depending on which coastal area they were at. All right, so now that we got our bearings on what this graph is supposed to show, let's see what the results are, and let's think about the main story that this graph tells. Well, if you look at the coastal area with no otters present, it looks like there's kind of not much of either. The sea urchin density is pretty low. It's less than 10. I mean, this density graph goes all the way up to 60, and so we're not even at 10 here. So sea urchin density is kind of low. Kelp density also kind of low. You know, they're both like, what, this is like 5-ish, 4-ish, you know. Pretty low, but they both exist. All right, let's move on to otters present for 2 years or less. You can see here, compared to the no otters present, if we're comparing sea urchins to sea urchins, well, there's fewer sea urchins, right? There used to be, I don't know, 6-ish, 5-ish, or whatever. Now there's like 1 sea urchin in the place, right? So when you have otters present for 2 years or less in a place, you have way fewer sea urchins, All right, well, let's look at kelp. Well, kelp, it seems like, went up a bit. I mean, I guess it like tripled-ish, you know, it at least doubled, and it went up by quite a bit. Although, you know, it's not like kelp is like out the box. It's not like way up here or anything. But there's like a lot more kelp, a lot fewer sea urchins, still not that much of either. And this is what happens when otters are present for 2 years or less. Kelp goes up, sea urchins go down. Now let's look at otters are present for 10 years or more. This is like an 8-year difference. This is a 2-year difference. This is an 8-year difference. Right? Here, otters have been in town for 1,000,000 billion years, and you can see that sea urchins, they are gone. No more sea urchins. Otters have eaten all the sea urchins. The sea urchins are gone. The sea urchins have all run away, too scared of the otters. Otters are way too dominant. Every time a sea urchin comes in, it just gets like ripped apart by like a dozen otters. Right? All right, and kelp, by contrast, is just like exploded. So much kelp. There are 50 kelps in every square meter. That's a ridiculous amount of kelps. I mean, look at this. This is only 10 kelps. 50 is so much bigger than 10. All right, 1,000,000 billion kelps, 0 sea otters. That's what happens when the 0 sea urchins. That's what happens when the otters are present for 10 years or more. There's no urchins at all and 1,000,000 billion kelps. All right, looks like, generally speaking, they're kind of, this is called, they're negatively associated. When one goes up, the other goes down. Seems like if you have a lot of sea urchins, you're not going to have that much kelp. And if you have not that many sea urchins, you're going to have a lot of kelp. And it seems like the main thing that's sort of putting its thumb on the scale here is whether there are sea otters there or not, right? If you don't have any otters, you're going to have a bunch of sea urchins and not that much kelp, and kind of not that much of either. But then as soon as you start introducing otters, right, this scale kind of tips in favor of the kelp. And this is because, again, if you look in the passage, right, this is because the otters are eating the urchins, and so there's fewer urchins to eat the kelp, so there's lots more kelp. Okay, so that's the main story of the graph. Let's go through in detail each of the answer choices and see how the claims that the answer choices make match up with the story that's told in the graph. All right, starting with answer choice A, and answer choice A is just right in here. In fact, 2 years or less of sea otters can completely eliminate sea urchins in a coastal area. Now, it's this word completely here that makes answer choice A wrong. And now let's look at it here. We're talking 2 years or less of sea otters. Here we're talking about this part of the graph. Here, this is the part of the 2 years or less of sea otters. And now they're saying 2 years or less of sea otters can completely eliminate sea urchins. And that's not true. In order for it to be true, sea urchins need to be completely gone. What we do know is that 10 years or more of sea otters can completely eliminate sea urchins because, look, they're gone here. But that's not true in the 2 years or less part. Here, sea urchins have been significantly reduced, but they're not completely eliminated. This touches upon a very familiar concept of logical strength in answer choices. Saying that something has been completely eliminated is a very strong statement. It's very difficult to prove true, and it's therefore less likely to be the right answer in the SAT because it's a claim that's harder to prove as true. As opposed to, for example, answer choice B, and now let's read this, and here we're going to replace the underlined portion in the passage with the entirety of answer choice B. In fact, even 2 years or less of sea otter presence can reduce the sea urchin threat. All right, so answer choices A and B are almost exactly the same. The only real difference is that whereas answer choice A says completely, answer choice B says can reduce, right? Here, the principal difference between these two is a difference in logical strength. Claiming that something can reduce something is a much weaker statement than saying that something is completely eliminated. Here, the only thing we need in order for this to be true is that the sea urchins need to go down a little bit. We could even literally reduce the sea urchin population by a single sea urchin, right? Like one otter shows up on like year one otter shows up, eats a single sea urchin, bounces. That's enough. The sea urchin's population has been reduced, right? So here, just to be specific, even 2 years or less of sea otter presence can reduce the sea urchin threat. Here we're looking at 2 years or less. We're wondering whether it reduces the sea urchin threat. We're looking at this low number, this low black bar, comparing it to this high black bar. This bar is higher than this bar, so it's been reduced. From here to here, it's been reduced. So this answer choice is correct. All right, on to answer choice C. In fact, kelp density increases proportionally as sea urchin density increases. All right, so what this claim is saying is that the kelp density is going to increase, and then that increase is going to be proportional to sea urchin density increase. So this is making a claim about the two different things we're measuring, the two types of densities we're measuring, sea urchin density and kelp density. And it's saying that when one goes up, the other one also goes up. When one increases, the other increases proportionally. Right? So a graph that where this claim was true would basically look like, well, like sea urchins go up, kelp goes down, sea urchins go down. They kind of go hand in hand. That's the opposite of what's going on in this graph. And here again, you can see it's kind of like the higher the sea urchins are, the lower the kelp is. And vice versa, like the higher the kelp is, the lower the sea urchins are. Here, kelp is super high. There's no sea otters at all, or sea urchins at all. Here, the kelp is kind of high, and there's like really very few sea urchins. And then here, when the highest the sea urchins get is also the lowest the kelp gets. So this is kind of the opposite of what's true. It's saying these two things are positively correlated when in fact they're negatively correlated. All right, on to answer choice D. In fact, even after sea otters were present for 10 years or more, and so that's here, right? Even after sea otters were present for 10 years or more, kelp density was still lower than sea urchin density. Okay, well, if you're looking at this, okay, so otters are present for 10 years or more. We want kelp density to be lower than sea urchin density. Well, what's kelp density? Kelp density is 50 kelps, million billion kelps per what? Square meter. Million billion kelps per square meter, 50 kelps per square meter. Let's look at sea urchin density. Well, sea urchin density is 0. All right, so question, is 50 a lower number than 0? Answer, no. This question is wrong. Now, this answer choice is wrong. Now, probably the mistake that you made if you selected D was either you mixed up kelp density and sea urchin density. You looked at this and you're like, damn, sea urchin density is way higher than kelp density. Look at this. And you forgot that this is kelp density and not sea urchin density. Or maybe you read this lower than and thought it meant higher than, or you mixed up the claim and you thought that they were trying to say that kelp density was higher than sea urchin density, and that sounded right to you. So if that's the mistake you made, the moral of the story really is, on these graph questions, make sure to slow way down. All of these claims aren't fundamentally very difficult to test as long as you understand solidly what the graph is about, what the axes are, the exact things they're measuring, and the meanings of these various elements in the graph. If you can slowly, methodically stick to checking part for part, word for word, claim for claim, each of these 4 answer choices, you're going to turn these quantitative information questions into guaranteed points. All right, that's all for this question. I'll see you in the next video.